Every 2 years, the U.S. Department of Energy invites collegiate teams from around the world to converge on the National Mall in Washington, D.C. What's the challenge? To design and build a house that produces more energy than it consumes. Let's find out more about this exciting competition of worldwide proportions.
The competition is very unique. There's going to be 20 homes on the Potomac Park in Washington, D.C. So we're going to be competing against these other homes, but it's going to be like a neighborhood while we're there. So people can tour the homes during designated times. So we're prepared to show this home off to everyone that comes out.
Well, the concept for the home was to design a traditional Midwestern style home that appealed to the broader residential consumer market. So we wanted to make something that looked like a house and not worry as much about how to transport it to DC. A lot of our competitors are doing some really innovative things architecturally with cubes and geometry. Our strategy was to create something that felt like a home. It does appeal to a broader market. When a lot of people are looking at solar-powered housing, they think spaceships, or they think a lot of steel and metal. This house looks like a home, and we want to encourage people that they don't have to sacrifice comfort to get a solar-powered house.
Being able to be a part of this project has really brought the classroom to the construction site, so to speak. We've done the energy modeling and a lot of these different calculations that we've learned in the classroom, but now we're actually coming out here and working with the field technicians in order to be able to implement this into the home.
One of the cool, efficient products in the house is called the BioWall. And it's a vertical plant wall that's connected to our air conditioning system. And it's designed to actually have the plants filter the air for the home. And so air is drawn through the plants, and they remove chemicals in the air, and they grow from it. And we get clean air and energy savings from it.
Some of the unique aspects of the control system are, from the thermostat, you can control the lighting in the home, you can control your door locks, you can control your security camera. You can also view all that from your cell phone or the internet. You can go on here, you can set up schedules, you can follow trends to see when you are using electricity for your air conditioning system that maybe you're not home. You realize that in the middle of the day on Sunday, every day it's running and you're out at the beach somewhere. So it's little things like that. You can go back and look at the trends and see where you've been wasting electricity.
This house is a phenomenal house. It's a real house. It's got a lot of innovative ideas in it, but what gives Purdue the cutting edge is the team. Besides a phenomenal resume builder, these students are learning to interact with all sorts of different disciplines that they would normally get out in industry. This project is one of the closest to real-world experience in construction, design, planning, implementation of a project.
Well, this is the Solar Decathlon. Therefore, we have to provide all of our electricity that we use for the house by the sun's energy. So that means we have to bring down all electricity through this inverter right here. That means we generate the lights, the appliances, the hot water. We have to do everything based off the sun's power. So by incorporating what we've all put into the in-home, the solar energy, the efficient lighting, the low VOC materials, you can be able to have these systems in this house at your fingertips tomorrow. You know, everything is commercially available. You can put this in your house, you can save electricity, and you can save the environment. It's for our good, and it's for our children's good, and for the whole future of the United States. This is something we really need to take a critical action towards.
The Solar Decathlon has become one of the most highly anticipated design competitions ever held, and Purdue's team has proven they're definitely up for the challenge. For Bytes, I'm Chris Nisley.